The three typical sizes of pipes you'll have here in your indirect hot water system. You will have your 15mm pipe, you'll have your 22mm pipe, and your 28mm pipe. 28 is generally for the expansion pipes, 22 is flow and return, so to and from, and 15mm for your wash hand basin and also your water closet, which is your toilet. To start there, we bring in our rising mains. That goes up there into our water tank in our attic. The rising mains is 15mm in diameter. Then we have our drain off valve, which is here, and we also have a valve over here that shuts off the water going to our sink if we need to change the appliance here or fix the tap or whatever we need to do. That's the way it's shown. We bring our supply of water then over to our expansion vessel. This is used here for our expansion pipe coming up here from our primary circuit, which is up from our boiler up to our cylinder. We have our cold supply of water come down here to our toilet and also to our sink, bath and our toilet down in our bathroom. There you can see we have a valve to turn it off in case you want to fix up taps or fix the toilet or whatever. The size of these, you have 22 to your bath and to your sink and your toilet there 15mm. And then we have our cold water supply coming down here to our shower, which is an electric shower, so that heats the water by an electrical element. We have to bring a supply of water over here to our cylinder, and there we have a drain off valve on it also. The water comes down there from our expansion tank down to our boiler, and that goes up to our tank again, and there we have our primary circuit. So you can see there, it's called an indirect hot water system because the coil here indirectly heats the water around. You see also this here is the immersion, so that's the electrical means of heating up your cylinder. So there you can see the water is heated here with the boiler, it travels up along here in to our coil here inside in our tank. That indirectly heats the water which is here, and the water in the coil goes back down to your boiler, is reboiled and back up again, and this moves by a convection current. So the hot water goes to the top, the cold water comes to the bottom. So we're going to look at our radiators. Here we have our flow to our radiators. They're going to be 22mm. Our up stands to our radiators, which is this part here and this part here, they're 15, and these pipes here are 22. Here we have our return, so that's going to be coming back along, and that's 22mm in diameter. So there you can see our circulation. We have a valve on either side, and we have our pump here, and this here shows the direction the pump is going. There, this is what it will look like on the boiler. Now we need to put in our controls. We have our main control center here with controls on the boiler, on the cylinder, and in the rooms. We also need a wire coming down here onto our circulation pump and a valve to close off upstairs and downstairs our throttling. So that's what the timer looked like in the room, or the thermostat I should say. There we have our controls inside the room, and we must bring our wires back then to the control center. So we have our thermostats in the room, they all go back to the control center, with thermostat on our cylinder, that goes back there to the center, and we have another one then on our boiler, that also goes back to the cylinder. So if I want to turn off the heat there, that'll send a signal to throttle down the valve here. It'll throttle down the circulation pump, because obviously you won't need the water circulating as much if you're not heating the whole lot, and you'll turn down the thermostat there in your cylinder also. Here we have our secondary circuit, and that there is going to supply the hot water to your bathroom downstairs and so on. So the water comes in here, is indirectly heated, comes out through here, and then you have it then in your taps. So we'll have a look there at our solar collector. The water is heated here, comes down along through our circulation pump, down into our cylinder. There we have a secondary coil, and that goes back up. We have our expansion vessel here instead of our expansion pipe, which we had over in the other system. So that's made up of a capsule which has nitrogen, and when the water is heated, that nitrogen will compress and that will take up the extra water in the system. Sizes then, we have our 28 expansion vessel, 22 flow and return pipes to the rads, 15 on the upstand, which is this part here and this part here. We have also our secondary circuit, which is 22 millimeters, 15 millimeters then up to our wash hand basing and our toilet, 22 to the bath, and our drain off valves, and our primary and flow circuit down here. We also have. This is the way you can do it also if you don't want to put in your floors, and just make sure you keep it extremely neat. Have a blue pen, a red pen and a green pen. Keep it really neat. Typical question. Wood burning stove as shown in the sketch is used to heat two independently controlled heating zones, one on each floor. So exactly as we did. Show 3 radiators, so I had 2, you have to show 3. It is proposed to collect a solar collector as shown in the sketch, so the exact same as we did before. Using notes free on sketch to show preferred location for the solar collector and discuss in detail 2 factors that influence your choice. So we need the south facing facade, you need it at 45 degrees. That's the way that would look there. You must put in the controls, and that's it. Control valves, your typical pipe size and your modifications there. That's it.